Okay, so today we're going to start with something you probably know how to do. And that's distribution. So I just want you to start by distributing 3 times x plus 2. So most of you are probably okay with this. We just distribute the 3 to the x, we get 3x. We distribute the 3 to the 2, and we get 6. So in essence, we've multiplied 3 times x to get 3x, and we multiplied 3 times 2 to get 6. And since the 2 is positive, when we multiplied 3 times positive 2, we got positive 6. That's why it's plus 6. Now I need to try something a little bit different. I need you to undistribute. So you just distributed. Now I want you to try to undistribute. Notice I've given you the same polynomial. So you should just be able to look above and kind of figure out what happened. So if we think about this as having parentheses, so if we're undistributing, it's kind of like saying, okay, well, what do we have to pull out of each of these things? Well, we can pull a 3 out of this parentheses, and that leaves me with a 3 times x plus 2. The question is, well, how did I know I could pull a 3 out other than I just did it the other way above? Well, that's because the 3 is a common factor. Okay, when I look at 3x and 6, the only factors they have in common is a 3. Okay? Because this is 3 times x and this is 3 times 2. And if distribution is multiplication, then undistribution must be like division. So I'm looking for factors they have in common that I could divide out. See, they both have a 3, so I divided out the 3. So where did the x come from? Well, when I divided 3x by 3, the common factor, that left me with only an x. When I divided the 6 by 3, the common factor, that left me with only a 2. Okay, so now I want you to see if you can apply this to this next problem. Okay, so we have 4x plus 20. I want you to try to undistribute this binomial. Okay, so we have to figure out what we can pull out of the 4x and the 20. Well, our common factor here is 4, because this is 4 times x and this is 4 times 5. But when I pull the 4 out, what's left? If I pull the 4 out of the 4x, that leaves me with just an x. And if I pull the 4 out of a plus 20, that leaves me with just a plus 5. So when I undistribute 4x plus 20, I get 4 times x plus 5. Now, how do I know that I'm right? Well, I could just distribute it back out again. If I distribute the 4 to the x plus 5, that would give me 4 times x, which is 4x, and 4 times 5, which is 20. I started out with 4x plus 20. I undistributed it and distributed it back, and I ended up with 4x plus 20. So that tells me that this was the correct answer. Now, undistribute is not really a word that we use. Undistributing is really called factoring. Okay, so we didn't distribute, or we didn't undistribute these two problems. We factored them. This is the factored form of 3x plus 6. This is the factored form of 4x plus 20. Okay, and that's what today's lesson is on, is factoring. Okay, so I want you to factor this binomial. We have 15x plus 25. Alright, well the first thing you should have done is find the common factor. Okay, well I see here that the common factor is 5. Okay, I can see that because this is 5 times 3 times x, and this is 5 times 5. So the only thing they have in common there is a 5. So I'm going to factor out the 5. So I've got my 5, but now I need to figure out what goes inside the parentheses. Well, to figure that out, I need to divide out the factor, or take out the factor. So I'm going to go to each term in my binomial, and I'm going to take out that factor of 5, or divide out that factor of 5. Okay. So now when I do 15x divided by 5, that's going to leave me with a 3x. And that's one of the terms that goes in my parentheses. And then when I divide 25 by 5, that leaves me a 5. So I have inside my parentheses 3x plus 5. So the factored form of 15x plus 25 is 5 times 3x plus 5. Alright, now those were pretty basic that we were looking at. So let's look at a slightly more complex one. We have 48x squared y plus 16xy squared. Now, some of you still may be able to look at that and recognize what the common factors are. But the question is, what do you do if you can't look at something and determine what the common factors are? Well, that's when we're going to factor each term. Okay, you probably remember this from previous math classes. We're going to use a factor tree. So I'm going to break down each of these terms using a factor tree into each of their prime factors. So I'm going to start with the 48x squared y. Okay, first I'm going to split this into 48 and x squared y, because 48 times x squared y is 48x squared y. Now I'm going to break the 48 apart into its factors and the x squared y into its factors. So 48 would break into 6 and 8, and x squared y would break into x squared times y. So 6 times 8 times x squared times y is still 48x squared y. And I just keep going. Okay, I keep going until I hit a prime number, which means it doesn't have any other factors, so I'm going to circle it. Y is the first one I hit. The only way to get y is 1 times y. So that branch, so to speak, is complete. But the rest of them aren't. So the 6 I can break apart into 3 times 2. 3 and 2 are both prime, so those are done. The 8 I can break apart into 4 times 2. The 2 is prime. The x I can break apart into x times x, and x is also prime. Any variable without an exponent, the only way to get that variable is 1 times itself, so that in a sense makes it prime. Well, then I still have the 4, so I have to do 2 times 2, and 2 is prime. So once I've ran into all prime factors, then I have the prime factorization for this term. So I'm going to write out everything I have. That says 3 times 2 times 2 times 2 times x times y. So this is the fully factored form for 48x squared y. Now I can do the same thing for 16xy squared. I'm going to break it apart into 16 and xy squared. Then I can break the 16 into 4 times 4, and the variables apart. Break both 4's into 2 times 2, and then break the y squared into y times y. So I have all prime factors for 16xy squared. Again, I'm going to write them out. Okay. Now, what was I looking for again? Oh yeah, I was looking for common factors. Well, I have a list of all these factors and a list of all those factors. Can I just look for what they have in common? Yeah. So I'm going to go through and circle the things that they have in common. I noticed that the first one has a 2 and the second one has a 2. There's one thing they have in common. Oh, but look, they both have another 2 as well. And another, and another. So in fact, they actually have 4 2's in common. But that's not it. They also have an x in common. Because see, here's an x and there's an x. Now this second x doesn't have another one to be in common with, does it? So I can't circle that one. Because although they both had one x, they don't both have a second x. So that's not in common. But they do both have a y. So I can circle a y. Notice again, this extra y over here doesn't have a pair, a match, so I can't circle it. But look what I've circled in each of the factors. I've circled 4 2's, an x, and a y. I've circled 4 2's, an x, and a y. So I'm going to write that down. So 2 times 2 times 2 times 2 times x times y, well, that would be 16xy. This tells me that my common factors of these two terms is 16xy. So I'm going to write that down up here, 16xy. Okay, now, the second thing that this helps me with is actually dividing out the factors. Because if I take out all the common factors, the only thing left is what I would get when I divided. So looking down here at all these factors, the only things I have left are this 3 and this x. Well, that tells me that if I divide 48x squared y by 16xy, that all I would get is 3x. And that should make sense, because if we divided 48 by 16, wouldn't that give us 3? And if we divided x squared by x, wouldn't that give us x? And if we divided y by y, that would just give us 1, so that's why we don't see that. All we have left is a 3x. And what about the other term? The only thing left over here is just a y. So when I divide 16xy squared by 16xy, I'm just left with a y, which makes sense because 16 over 16 is 1, x over x is 1, y squared over y is just y. So then I can put those terms inside the parentheses, and I have my factored form for this binomial. Okay, notice there are some tricks you could notice, so to speak. If you're looking at the variables, you're really just seeing how many match. I've got 2 x's and 1 y, 1 x and 2 y's, so the only thing that matches is 1 x and 1 y. That's why I was only able to factor out x, y, one of each. And then the numbers, you're really just going to have to get good at factoring those or noticing the factors if you want to be able to do those without the factor tree. But a lot of you are pretty good at recognizing common factors because you use that when you're simplifying fractions. Okay, now we've come to the practice portion of the video. I have given you some problems to factor. You need to pause the video, try to factor all of them completely before you finish watching the video, and then watch and make sure that you did them correctly. so notice some of them are similar to the ones we've seen so far. They're binomials. You're looking for common factors. Some of them are trinomials. Do you think that really changes what we're doing? Okay? No, we're still looking for common factors that we can pull out. The only difference is we have 3 terms that we're looking at instead of 2. So the factors need to be in common for all 3 of them, not just 2. Okay, so go ahead and pause it and then see how you did. Alright, so for the first one, I see that I have a 5 here, and then this 15 is really a 5 times 3. So there's another 5. Okay, that's the only thing they have in common, so that means my common factor is 5. When I factor out the 5, in essence, I'm just taking away those 5s, 1 5 from each term, which leaves me with just a squared minus 3. Alright, so then for the second one, the 56 is really an 8 times 7. So I see that I have an 8 in common and I have an A in common. Alright, so that tells me that my common factor is 8A. So when I take those factors out, then that first term only leaves me with an X. And the second term only leaves me with a 7. So I have a minus 7. So this factors into 8A times X minus 7. Because see, each term had an 8 and an A, an 8 and an A, and then that left me with just an X and a minus 7. For number 3, I see that 10 is really a 5 times 2, and that 25 is really a 5 times 5, and that n squared is really an n times n. So I see that I have a 5 in common and an n in common. Okay, so my common factor is 5n. So when I take out those factors or factor them out, that leaves the first term with just a 2. And that leaves the second term with a 5 and an n. So that's 5n. So this factored form is 5n times 2 minus 5n. Number 4, again, like I said earlier, it's not really different because there's 3 terms. It's just the common factors have to be in all 3 terms, not just 1 or 2. Okay? So I'm looking, I only have an x here. I see this x squared is really an x times x, and the x cubed is really x times x times x. Now, why did I not worry about expanding out this y squared? Well, because I already see my first term doesn't have a y, so there's no way that any y's are going to be a common factor. Okay, so I see that all I have is 1x in each term. That's all I have in common. That's all I could possibly have in common since the first term itself was just an x. It can't have anything more than an x in common. Okay, so I know that I'm going to be factoring out just an x. So when I cross out those x's, then I see what I have left for inside my parentheses. First thing you need to remember, when we're crossing out, what did we really say factoring was doing? We were dividing the common factors, right? So I really divided this x by x because the common factor was x. And what is x divided by x? It's 1. Okay, that is one of the more frequent mistakes, is if one term is the common factor, people tend to just leave that term off. But it doesn't go away because when you divide it by itself, you get 1. Okay, so that should be 1 plus, when I divide out this x here, that leaves me with x times y. So xy plus, when I divide out this x, that leaves me with x squared, y squared. So x squared, y squared. And again, we always said that we could just distribute back out to see if we got the right answer. If you think about that for a second, you can see why this 1 is necessary. Because when you distribute, if this 1 wasn't here, where would the x come from? Okay, you need this 1 here so that when you multiply your x, you get your first term of x back. Okay, so you cannot leave this 1 off. Okay, if you had 3 different terms here, then inside the parentheses you're still going to have 3 different terms. Alright, so the same thing for number 5. I see that my 10 is 2 times 5, and then the h cubed is h times h times h. The n cubed is n times n times n. For the second term, I have a 2 and h, and then I have n squared. So n times n. The 14 is really just a 7 times 2. Now, I notice on this one that I've almost had to write everything out again anyway, so it may be less confusing if I just go ahead and write everything out. So that's what I'm going to do. I'm going to go ahead and put the times h times n and the times h times 2. That way, I'm only having to look at my factors and not having to look back here at the original problem. So now I'm looking at what they have in common. Well, I see there's a 2 in each of these factors. Also, see that there's an h in all of these factors. And there's an n in all of these factors. So that makes my common factor 2hn. They each have 1 2, they each have 1 h, and they each have 1 n. There's nothing else that all 3 of them have in common. See, these two, there's another n and another n, but there's not another n on this one. It has to be common for all 3 terms, not just 2 of the 3. Okay, so now I need to figure out what happens to these terms when I factor out the 2hn. Well, the first term, when I take away the 2, the h, and the n, that leaves me with a 5, h squared, n squared. Okay, minus, because this one was minus to start with, that leaves me with just this n, so minus n. Then plus, on the third term, I'm left with just a 7, so I have just a 7. So this is the factored form of this original trinomial. So if we're looking for some maybe steps or thoughts to organize our process, then a good step 1 would be to find the factors of the coefficients. You always kind of have to look at the numbers separately. Okay, like on number 2, I had to find the factors of 8 and 56 and realize that they both had a factor of 8. Number 3, factors of 10 and 25 and realize they both had a factor of 5. Okay, so I have to find the factors of the coefficients. Then I have to find the factors of the variables. Most people find this easier than the coefficients because it's very easy to see the common factors of the variables because it just tells you which variables you have and how many. Like here, I have 3 h's, 3 n's, only 1 h and 2 n's, and only 1 h and 1 n. So the most they have in common is 1 h and 1 n. Okay, and then step 3, I divide each term by the common factor. Okay? Once I determine what the common factor is, then I divide each term. Once I figured out on number 1 that the common factor was 5, then I divided 5a squared by 5, and I divided minus 15 by 5. And then the last step would be to distribute to check your answer. Because if you distribute your answer, then you should get back the original problem that you started with. So this is how we factor polynomials by finding the greatest common factor.